Alright, let's go over the quiz. This is Precalc quiz number 18, section 5.1 on trig identities, expressions, and equations, taken on April 28, 2018. Multiple choice directions show, circle the best answer. Question number 1 says, find an expression that completes the fundamental trig identity. You should recognize that you have a negative here, so this is called the negative angle identities. Or they also call this the even odd identities. You could just look at your formula sheet and recognize that for cosecant, the negative sign kind of comes out in the front. So whatever that negative angle is, that negative comes out in the front. For cosine and secant, there is no negative sign. So your answer choice is A. Number 2, find the expression that completes the fundamental trig identity. I have secant of pi over 2 minus theta. You should recognize that that pi over 2 is like at 90 degrees. 90 degrees minus the angle. Well, if you have a 90 or pi over 2, I want you to think of complementary. Cofunctions are complementary. An example of that is just blank plus blank equals 90. So the cofunction for secant is cosecant. Again, that should just be a direct identity that you're using. Question number 3, I asked you to fill in the blank because obviously I made a mistake. None of these are to be your answer. Sine of 13 degrees equals cosine of blank. So cofunctions are complementary. Blank plus blank equals 90, so this is 13. Therefore, you subtract 13, then the angle that you're missing is 77. So the answer is 77. Question number 4. Multiple choice, use the fundamental trig identity to simplify. So here I have cosine squared x times sine squared x minus cosine squared x. You should recognize that they both have a cosine squared x, and that becomes my greatest common factor. I'm left with, in the parentheses, so cosine squared x times sine squared x minus 1. Now this should give you a hint that this is the form of the Pythagorean identity. Sine squared plus cosine squared equals 1. If I want to match here, I'm going to have to move this 1 to the left side, subtract 1, and then move the cosine to the other side. And you get sine squared minus 1 equals negative cosine squared. So there's my substitution. Every time I see sine squared minus 1, I'm going to put in negative cosine squared. Positive times a negative is a negative. Cosine squared x times cosine squared x equals cosine fourth to the x. Remember, it's kind of like x squared times negative x squared, right? Same base, you're adding the exponents. Question number 5. Multiple choice, use a fundamental trig identity to simplify. Sine squared x over 1 minus cosine squared x equals 1. Same thing, you're going to look at the Pythagorean identity. So notice you have to start with your identities, know them well. Now to match this, 1 minus cosine squared x, I'm just going to subtract cosine squared x from both sides. This will cancel. And then I'm left with sine squared equals 1 minus cosine squared. So there's my substitution. I see 1 minus cosine squared x, and I'm going to replace that with sine squared x and simplify that. I can cancel, and you're left with a 1. And which identity did I use there in pink? That is the Pythagorean identity. That would be choice V. Question numbers 5 and 6 are solving trig identity equations. solve the equation over the interval of bracket 0 to 2 pi parentheses. So I have 2 cosine x plus 1. And I'm going to try to solve x. Subtract 1 from both sides. Divided by 2 on both sides. I have cosine of x equals negative 1/2. I want to get x by itself. I'm going to take the inverse. Taking the inverse means switching these. So I have my calculator ready equation. The inverse of cosine of negative 1/2 equals x. I'm looking where cosine is negative. All students take calculus. Cosine is positive in these two quadrants. So I have to look in these two quadrants. Remember, cosine using your unit circle is the first order pair. Cosine then sine, so that is a negative 1/2. Remember the counting technique, 1, 2, 3, 3, 2, 1, and then when you count back up, 3, 2, 1, 1, 2, 3. So cosine is negative 1/2 at this location, which is 2 pi over 3. And then over down here at 4 pi over 3. So basically you could substitute in these values. Cosine at 2 pi over 3 is negative 1/2. Negative 1/2 times 2 is negative 1. Negative 1 plus 1 equals 0. So that's another way of checking your answers. Same thing with 4 pi over 3. Substitute it in, evaluate, multiply by 2, add 1, and it'll equal 0. Question number 7. Solve the equation on the interval. 2 sine squared x equals sine x. Hopefully you didn't do this, but don't divide. Do not divide both sides by sine of x. The reason why that happens, if you did that over here, I think I showed you in class, if you divide by x, you get x equals 1. But if you, so this is wrong. What's right is if you subtract x from both sides, and then you factor out an x, you'll get x to be 0 and 1. So when you divide, you'll actually eliminate one of your solutions. So that's why over here, don't divide by sine of x on both sides. Subtract sine of x, greatest common factor, which is sine of x. Notice how they both, remember if you're kind of stuck on the notation of sine squared x, just write 2 times sine of x, that expression squared. So I'm just factoring out a sine. You're left with 2 sine x minus 1. And then you're going to apply the zero product rule, which means you set each of those equal to 0. Here I get sine of x equals 0. Take the inverse. Where is sine 0? That is at 0 and pi. Remember, there's sine at 0. They're at 180 degrees or at pi. There's my two answers here. And then where is sine of x equal to 1/2? Sine is 1/2 at 2 locations. Here at pi over 6 and at 5 pi over 6. And these are my two solutions, so you have a total of 4 solutions. When you substitute in the value of x, both sides of the equation are true. So there were 7 multiple choice questions plus the 2 points for your name and the period, so that side was out of 16. Alright, on the back side of your quiz, number 8, for your response, make sure to show all your work, box your answers. Number 8, use identities to write each expression in terms of sine and cosine, and then simplify. So in this problem, I have tangent plus cotangent minus secant times cosecant. Tangent, I turn into sine over cosine by the quotient identity. Cotangent, turn into cosine over sine by the quotient identity. And secant times cosecant, I just turn into 1 over cosine by the reciprocal identity. And cosecant is 1 over sine. Here, this expression turns into negative 1 over cosine sine. That means I need a common denominator of cosine times sine. This one has sine, but it's missing cosine, so I'm going to multiply by cosine over cosine. Over here, I have I have a cosine but not a sine, so I'm going to multiply by sine over sine, so I get sine squared over sine cosine plus cosine squared over sine cosine minus 1 sine cosine. And then I can just, now I have a common denominator for all of them. It's really sine squared plus cosine squared minus 1 all over sine cosine. Sine squared plus cosine squared equals 1. So 1 minus 1 is 0 over sine cosine, or the answer is just 0. If you did all this but got stuck here, then I give you 3 points if you knew the Pythagorean Identity. Some common mistakes that I recognize students are making. Some students are trying to do this. I saw a lot of students try to cancel a sign and a sign here, but this is a plus. So these are not factors. Factors means multiplication. So you can only cancel if you see multiplication, such as 2/3 over 3/4. Here you can cancel the 3's, cancel the 2's. You can do that because it's multiplication. But if it was addition, you can't do that. Okay? Alright, question number 9. Solve the equation on the interval 0 to 360 degrees. Notice how it says degrees there. Sine squared x minus 3/4 equals 0. I'm going to add 3/4 to both sides. I have sine squared x equals 3/4. I'm trying to get x by itself here. Remember, you can write sine squared x as sine x squared. I'm going to take the square root of both sides. Notice how you'll get both a plus or minus radical 3 over radical 4. Here, that means square root of 3 over over 2. I'm looking for all the locations where sine is both positive radical 3 over 2 and negative radical 3 over 2. Each of those has 2 locations. Here at 120 degrees, remember sine is the second order pair, so my counting technique, 1, 2, 3, 3, 2, 1, we count up, 3, 2, 1, 1, 2, 3. So sine is radical 3 over 2 here at 120 degrees. Over here, sorry, that was 60, 120, 240, and 300 degrees. So your 4 solutions are 60, 120, 240, and 300 degrees. If you left all of those are correct and you put them in radians, I took off the point. Remember, this is just the idea when you're square rooting an equation, such as x squared equals 9. If you take the square root, your answer is plus or minus 3, because you could put in both positive 3 and a negative 3 squaring equals a positive 9. If you got 2 of these correct, I gave you 3 points out of 4. So double check you know your unit circle. The last class didn't want to use 500 push-ups to use their unit circle, so I think you're just going to have to memorize and know how to do this to evaluate. Alright, the backside question number 10. A lot of students probably found this one more difficult. Given cosine of alpha equals 1 over radical 5, and alpha is between 0 and pi over 2, given sine of beta is negative 4/5 and beta is between negative pi over 2 and 0, use the trig identities to find whatever they're asking you for. So you have to think about it. There's 2 letters. There's angle alpha and angle beta. Here in this problem, they're telling me to look at beta. I'm trying to color code that. Beta is all of the clues here in blue. Well, I know that it's in quadrants 4. The reason why it's in quadrant 4 is because it says 0 to negative 2 pi. Negative pi over 2. So this is 0. And remember, negative angles go actually clockwise. So there's your hint. Now, if you're not drawing triangles, You're not using Pythagorean theorem. You're not using x, y's, and r's. You're not using opposite over the adjacent. You're using what? Trig identities. If they give you cosine, or we're trying to find cosine, and in blue, I have the information for sine. So I can do sine beta squared plus cosine beta squared equals 1. That is the Pythagorean identity. From here, we just evaluate. Negative 4/5 times negative 4/5 is 16 over 25. This 1, I just make a fraction and multiply by 25 over 25. The reason why I do that is so when I subtract 16 over 25, 1 minus 16 over 25, or 25 over 25 minus 16 over 25, is 9 over 25. Cosine of beta squared equals the square root of 9 over 25. Remember, this is the square root of 9 over the square root of 25. Now, you should also know that it's a plus or minus. So the square root of 9 is 3, and the square root of 25 is 5. So my fraction is cosine of beta equals plus or minus 3/5. We're in quadrant 4, so all students take calculus. That tells you the C is that cosine is positive here. So I'm only accepting the positive, not the negative. So my answer is 3/5. A couple of mistakes here. The student who got square root of 41 over 5, I gave you 3 points. I think you did that because you thought negative 4/5 squared is negative 16 over 25. And then you add it over here. That'd be incorrect. Remember, negative 4/5 squared is negative 4/5 times negative 4/5. Also, if you got 3/5 drawing the triangles using x, y, and r, I only gave you 1 point or 0. Question number 10b. It wants to know the secant of alpha. Well, alpha, you have this information here. Alpha is between 0 and pi over 2. Here's 0, and here's pi over 2 on the unit circle. So that means alpha is here in quadrant 1. Alpha, they gave us the information that cosine of alpha is 1 over radical 5. So I need to find secant. So secant of alpha equals 1 over cosine. Reciprocal identity. If I substitute in for cosine, I get 1 over radical 5. Now, I'll show you my answer. 1 divided by 1 over radical 5. Change it to multiplication. Take the reciprocal. 1 times radical 5 is radical 5. Now for the student who wanted to rationalize first, your answer is 1 divided by radical 5 over 5. You change that to multiplication, you take the reciprocal, you have 5 over radical 5. Here to rationalize, I would just multiply by radical 5, so you have 5 radical 5 over 5 times 1. You don't need the 1 and the 5's cancel, you're still left with radical 5. Question number 10c. I need to find tangent of beta. I told you guys that you can find your answer for these two and then use that for the third question. Tangent of beta means I need to use cosine of beta. Now there's actually 3 ways that I solved it. You could have used the quotient identity. Tangent of beta equals sine beta over cosine of beta. Or you can use either of these Pythagorean identities. 1 plus tangent squared beta equals secant squared beta. Or 1 plus cotangent beta equals cosecant squared beta. Now I chose to add these on my solutions because I saw other students use that, and that's great. I'm just going to show you what I did. tangent of beta is equal to negative 4/3, I got that by putting sine of beta, which is your given information, which is negative 4/5. Cosine of beta was 3/5, and we got that from question 10a above. Write them sideways. Do not change the fraction. Negative 4/5 divided by 3/5. This changes to multiplication, and then you're going to take the reciprocal. Negative 4/5 times 5/3. My 5's cancel there, and you'll get tangent to be negative 4/3. In either of these questions, if you wrote down the identity you're using for the problem, I gave you 2 points. And you're simplifying, let's say you made a basic mistake, I gave you 3. And of course you need to show all your work using identities to get full credit. If you struggled on this quiz, I would highly recommend going back and studying and knowing your identities, not just having the formula sheet next to you, because you can have it and not know how to use it. That side was worth 20 points. The front side was 16, and the quiz was out of 36. Study.